For example, we will fix the instrument here. Okay, so consider this is an theodolite, we will fix it. So this point is, take it as an O. Okay, so next, so this is another object. So this is another object, whether it should be A or B, whatever object is there, whether we are considering building or tree, so whatever object we have to focus. Okay, so from this object to this object we can find out the angles. Okay, so that thing only we have to find out the, with the help of theodolite we have to find out the horizontal angle for from A to B. Okay, so in that we have to consider, so we have preliminary adjustments before fixing this theodolite. Okay, so there is the theodolite. So before fixing the theodolite, so we have to place it tripod. So whatever locations we have to fix it this theodolite. So on that we have to use the theodolite with this is screws are there, we can tighten this tripod, we have to fix it this theodolite. Okay, so on what we have to consider mean, so we have to fix the plane, so whether we are finding the angles. Okay, so before we have to set the horizontal axis with this help of theodolite. So what we have to do means, we have 3 foot screws there. Okay, so the foot screws, the main purpose, this is the bottom of the foot screw. Okay, so these foot screws only we can adjust the theodolite based on horizontal axis, then only we can find out the exact reading from A to B. Okay, so these foot screws are there, whether we have to apply, so we have to adjust the foot screw, whether it should be clockwise or it should be an anti-clockwise. For example, so once we fix this theodolite, we have to use 2 foot screws, whether it should be clockwise or anti-clockwise. So automatically the plane of the theodolite, it should be from stable. So with the stable we have to easily find out. Here we have leveling tube is there. Okay, so with this leveling tube we can easily whether find out the plane, it should be horizontal or not. Okay, so we can using with this foot screw whether it should be clockwise or anti-clockwise. So next step we have to do another one. So another foot screws are there. So this foot screw has been adjusted by same simultaneously, whether it should be a clockwise or anti-clockwise, we can find out this thing. Okay, so how we take the reading. Okay, so whether we fixed, whether it should be a horizontal with a, whether we see the bubble tube, it should be centered or not, we will check. So next of all what we have to do means, we have to, so there is 2 screws are there, one is upper plate screw and then lower plate screw. So when we adjust, when we tighten the lower plate screw, the instrument does not rotate. Okay, instrument does not rotate. So if you remove the lower plate screw, so automatically the instrument, it should be rotate. So where we apply this concept means, so wherever the point we have to find from particular O point to A and B, so we fix the instrument, but instrument does not any movement there. So that thing we have to adjust both the upper and top screw. So if you tighten the both upper and top screw means the instrument does not any rotate, so there is no movement in that instrument. Okay, so if you want to take the reading from object A to B, we find out the angles, so we have to loosen the bottom screw. So automatically what will happen, the instrument will automatically rotate. So if we tighten the both, the instrument does not rotate. So with this concept only we have to apply the angles. So before we taking the angles, so already I said what are the verniers are available in that theodolite. So vernier A and vernier B is there. So main scale it should be 0 to 360, the vernier A and B. So when we consider for horizontal angle, so vernier A and vernier B is there. For we are taking horizontal angle, so vernier C and D is placed on the top of the theodolite. Okay, so with this instrument what we have to do, so both the horizontal angle as well as vertical angle. Okay, so this is the telescope, we can see the object. Okay, so in this theodolite, this is eyepiece, this is object piece. So this is the target. So what we done in gun, so like that the target, we whatever the object we are directly focused with, this the target eyepiece. So there is two adjustments in this telescope. Okay, so this it should be whether we be zoomed or not, we can blur. So whatever object we can focus with the help of this adjustment. So eyepiece, it should be mainly used for seeing the object whether it should be cleared or not by focusing, by adjusting this eyepiece. Okay, so this thing the main concept behind in this theodolite. So what the main purpose we are doing is from this instrument we are going to find out whether it should be horizontal angle and vertical angle. Okay, so if you take it the horizontal angle, so we can find out the angle from 0 to 360 by what are the objects are available. For example, if you are focusing A and B point, okay, so we have to find out these angles of A to B, we can find out with the help of this theodolite. For example, so the angle, so coming to find out the readings. So angle, it should be denoted in degree, minutes and seconds. Okay, so angle in terms of degree, minutes and seconds. Okay, so for considering the reading, the vernier A, for example, for calculating vernier A, so we are getting, so for degree and minutes we have to consider vernier A. So we have to consider minutes and seconds, we are going for vernier B. Okay, from vernier A we have to find out two things, one is degree, minutes. So B we have to consider minutes and seconds. Okay, so how we can finally the angle, it should be in degree, minutes and seconds. Okay, so this is the basic concept behind in that theodolite. Okay, so how we find out the angle? Okay, so what we have to do means, so already I said the main scale, it should be 0 to 360. So how it came means, so for example the main scale, so this is the top view of theodolite, the main scale from 0 to 360. Okay, so from that, so vernier A and B is there, vernier A and B is fixed in middle of the theodolite. So vernier A and then the main scale is 0 to 360. So what vernier A it indicates in main scale, so that it should be degree and minutes, degree and minutes. Before going to the reading, we have to know what is the least count of this theodolite. So least count, it should be 20 minutes. Okay, the main scale how it indicates means, so this is the 0, this is 20, 40 and then what, 20, 40. So 0 degree, 1 degree, 2 degree, 3 degree, 4 degree and then 5 degree. Okay, so for example, I already said the least count, the least count it should be what, 20 minutes. So this is 0 degree, so this is 0 degree 20 minutes, this is 0 degree 40 minutes. So again, if 40 means again 60, so 60 means it should be an 1 degree. Okay, so automatically we can find out. So this is the main scale reading. Okay, so we adjust the vernier, so vernier also they having same least count, vernier also having same least count. So vernier A, so vernier A is indicate what in main scale, so that it should be take it as degree and minutes. Okay, so and then vernier B also available in the opposite direction. So from that, from 0 to 5 degree, what is be coincident? Okay, for example, if we consider this diagram, so if we consider this is an vernier B, so this vernier B, so from 0 to 5 degree, there is some coincidence between vernier B as well as vernier main scale. So if you are considering, for example, these 2 points are coincide, so we take in as this 0 degree, this is 1 degree, exactly 1 degree, it should be 1 minutes, it should be an minutes and seconds. So we have directly taken as this point, for example 1 minute 0 seconds, it should be a vernier. So we have to club vernier A and B, directly we will get degree, minutes and seconds. Okay. So we can easily, with the help of tripod, we will fix this instrument, right. So afterwards what we have to do? So for example, we see the object or whatever the place we have there, we can easily find out. Okay. So another one instrument, that is, it should be a leveling staff. Okay. So this leveling staff, the main purpose for finding the different levels of ground surface. For example, this leveling instrument, it should be leveling staff, mainly it come under for around 5 meter length. Okay. So in each and every meter they have some divisions there. So we can easily adjust by each and every 1 meter. Okay. So in that main concept behind, so why we are choosing white color, red and black? Okay. So we have to know. So for example, we can see around 90 to 100 meters range, we can easily focus by this theodolite. Okay. But we can easily seen by eye with the help of the telescope. So for identification purpose, so it should be in black and white, it should be then only we can easily focus the values. Okay. So the main purpose for leveling staff, to level the surface, so we have to take out the reading. So there is some measurements there. Okay. So with the main thing we have to done with in terms of meters, and then the least count of this leveling staff, it should be 0.05 meter. So each and every black and white, it should be 0.015. For example, this is a 1 meter, right. So this is 1.5. So 1.1, 2, 3, 4 and 5. This is the 1.5 meter reading. So each and every black and white shade, it should be 0.05 mm. Okay. So these things only we can find out the leveling instrument. So these are the basic concept and what are the things involved in this theodolite. We have to take this theodolite in the ground level, then only we can what are the things available there. So what are the things what happened in the site, that and all we can easily find out. So different angles also we can find out this help of instrument. Okay, thank you. You have little bit understand about what are the thing we have to find out the horizontal angle. So main thing we are using theodolite. So many things we have find, but in this session we are only discussed about horizontal angle. So we will see the next class. So what are the things we happen in with the help of theodolite by vertical angles, elevation, distance, everything we can find out. See you in next session. Thank you.